by UNESCO. Whereas Professor Mukhopadhyay acted as a metadata consultant for the project NDL, National Digital Library, all of you must be knowing it, hosted by IIT Kharagpur. He is presently a member of Advisory Committee for National Virtual Library Project of Ministry of Culture, Government of India. He developed Vidya Online as e-learning portal for Vidyasagar University in 2006 and presently running 3 online courses in SWAYAM platform. So he's a tech-savvy man, and as I told you, that he's a man who's working on the open source, and basically, I don't know whether you know him, that he's very much he coordinates all the problems which are associated with the Koha. So he has taken keen interest on open source softwares, and especially on the DSpace or Koha or any other software where you need his assistance. You can always just be in touch with him. He will be ready to help all our professionals. With these words, I invite you, Professor Parthasarathi, and today he'll be speaking on an interesting talk on AI in libraries, automated indexing, and retrieval augmented generation. So the topic seems to be heavy for all of us. Let's see Professor Mukhopadhyay what he has to say on this. So with these words, I invite you once again, Professor Parthasarathi, to just interact with the audience and share your experience and expertise on this area. Over to you, Professor Mukhopadhyay.
Yeah, thank you, sir, for all the kind words. Professor Raja and myself are a long time friend, almost 10 years, I think. So
since Shillong, we know each other.
Yeah. So welcome to all of you, dear delegates, dear colleagues present here. So as Professor said, we'll be exploring an uncharted path here, and that is AI applications in library domain. Possibly you are hearing here and there that we have entered into the era of AI/ML, artificial intelligence and machine learning. And we need to, library professionals are most enthusiastic technology user right from the time of Gutenberg. It's not a new thing. It was there, it will be there. So what this new AI/ML technology, what are the possibilities, what we can do with it, how we can enhance our, knowledge organization and retrieval, two of the most important aspect of our profession. We are basically metadata people. We organize documents and we, provide different avenues, highways and byways to retrieve those organized knowledge objects. That's the thing. And in both the cases, AI/ML can do a lot. So my plan for this 1 hour 30-minute session is that I will be briefly discussing about the AI/ML, how this technology is different from the rest of the computing technologies, what it is trying to achieve, and what we are going through presently, and how we can apply that thing in our library system under 3 groups. We will be categorizing all the tools under 3 groups, but I will be concentrating on the group C, that is the 3rd group, which has much more potential in our domain. So let's start our process, and someone please report me whether you can see my PowerPoint slide or not. Is it visible?
Yes, sir, visible.
Okay. Fine.
Yes, sir.
Okay. So as you see that artificial intelligence is basically a multidisciplinary and interdisciplinary domain. And I will be showing you that library professionals have an edge in this particular technology. We have a lot of pre-level data. We have a lot of ready data set to deal with, to train the machine learning backend so that it can provide us the required feedback. So with this age, in comparison with other professionals like computing professionals, we are having a slightly advantage here because we have ready-made training data set. What we need to know the ins and out of the process, what are the different key technologies associated with the process, and what we need to learn. Because we are basically passing through an era of lifelong learning. As a library professionals, we need to learn, almost every day in our professional life. So this is a new learning process, of course, and many things are still blurred. So we are already planning to start a certificate course on AIML applications in library services. Let's see what it goes. But let's have a brief overview of this. If you are not living in an isolated island for the last many years, you have heard that the concept of chat GPT. Many of you have utilized GPT models like Google Gemini model, Bart model, Llama from Facebook, or chat GPT from OpenAI. Also, all on a sudden, you might think that the technology came from the sky. It's actually not. Nothing like that happened in human history. Everything has its roots. And in case of AIML, what we call normally this kind of effect, that all on a sudden a technology became very popular, omnipresent in almost every walks of life. So that is called bamboo sapling effect. It was there because this happens with bamboo sapling. Until 5 years, suppose today you have actually planted a seed, and until 5 years you won't be seeing any kind of change. Then all on a sudden, after 5 years, the sapling will come out of the land or soil, and it can grow up to 90 feet within 5-6 weeks. So exactly that bamboo sapling effect is a very common effect, common phenomenon in science, that exactly happening with AIML also. The root was there in 1936 when Alan Turing, many of you have definitely seen his biographical film called Enigma. So that genius British mathematician Alan Turing first proposed the concept of can machine think, and that paper actually the starting point of all kind of AIML applications. So before making a quantum jump inside the process, as I said, that this computing technology is slightly different from other technologies. And within computing technologies, artificial intelligence and neural networks are completely different from other computing technologies. Why I am saying so? And with so much of confidence. Because my dear friend, if you see the any technology in the society around you, like suppose you are sitting under a ceiling fan, or you are running your AC, or you are accessing your web conferencing software like this, all are basically extension of the 5 sense organ of human beings. Hand, legs, eyes. Say for example, when you are seeing in microscope, that's an extension of eye. When you are seeing in telescope, that is also an extension of eye. You are taking a bus or train to communicate from one place to another place. Extension of your legs. So computing technology is different from all other technologies available in the human society right from the beginning, that this technology is the only technology which is trying to imitate our brain. No other technology tried to imitate our brain. Everything extension of different human organs, our eyes, our different sense organ, hands and legs. But this technology is directly targeting the human brain to imitate the human brain, how human brain works. And it's basically a kind of technology, if you see the names of the model, like neural network model, it directly trying to imitate the process through which human being process information inside the brain. Okay, so if brain is the core thing, brain is the target domain of this technology, how our brain evolved. And you will be surprised to know that that makes human being completely separate from other members of the animal kingdom, our brain side. You see there the history of the over 2.5 million years, how the different species and genus, what we today call Homo sapiens, came here, and how the skull size of this species are growing. So this is the present generation of Homo sapiens, the skull size, and everywhere from this picture it is visible, right from the Homo habilis to Homo erectus to Homo sapiens, the skull size is increasing like anything. And what's the reason? The growing size of the skull is to accommodate, the purpose is to accommodate more and more gray matter. And if you compare our nearest relative in the animal kingdom, chimpanzee, and compare the brain size of chimpanzee with the brain size of modern Homo sapiens, it's almost 5 times. So around the average, it is around 450 chimpanzee, and for an average modern human being, it is around 2000 cc, cubic centimeter, the brain size. And interestingly, brain is the most costliest device in your human body system. Even when we are doing nothing, we are in deep sleep, then also the entire 25% of the entire body energy our system spend to awake our brain. Our brain never sleeps. When you are in deep sleep, then also your brain is awake. It's a, uptime is 24/7. So it's a very costly device. And in terms of evolutionary biology, many of you are from biological science, maybe you all know that over the journey in the evolution, mostly that organ, that particular part survive, which gives us result. But that never happened with the human kind. The brain is the most costliest device, and for last 2 million years, brain has given us nothing. Why I'm saying so? Because if you again see the different kind of tools we have developed, because we have utilized our brain to develop different kind of tools, we were insignificant in the food pyramid. If you imagine that 2.5 billion years back, the emergence of the Homo sapiens as a species, we were only having the brain as a tool. We never know how to run faster. We never grown our muscle. We never increased our teeth length so that we can fight back to the larger animal. No. We only invested entire energy to develop our brain, and we were insignificant. Any other members of the animal kingdom can easily hunt us. We were easy prey. And our brain for the 2.4 to 1.5 million years ago, if we take calculation from the backside, so it was giving this kind of tools made up of rock. And another 1 million year we took how to sort them. So for the first 1.5 years, really, really amazing that there is no answer to this biological, fallacy, that your one particular organ is not giving you back anything, only a certain kind of learned tools, and then also you are investing a lot of energy, over the years on that particular organ. Nowhere it happened. Only with the human species it happened, and still biological scientists do not have any answer for this puzzle. And then we developed many other tools again. This is basically Herculean tool. Then we came to Paleolithic tools, and only around 40,000 years ago, if you calculate the human society, human brain gave us this kind of tools only. It becomes harper, it become double-edged. This you can say predecessor of the arrow, and so on. An arrow is the predecessor of the missile. The time and given us tool. We are the tool making species. This is the only difference between the human being and other members of the animal kingdom. We make tools to comfort our life. That's all. And that tool making capability is coming from the brain, and first 2.2 million years, brain almost given us nothing. Then all on a sudden, something happened. That is also a bamboo sapling effect. If you take the entire human history over the last 2 million years, so Homo habilis, Homo sapiens age, almost, this 1 lakh years of ago, Then 40,000 years ago, tribal community, tribal age came, and agricultural age came only 7,000 years ago. And that made all the changes in the human capability. Because previously we were hunter-gatherer. Brain gave us some, mechanism to develop tools so that we can break the bones, to take the bone marrow, to kill the smaller animals, but not much. But the moment we invented agriculture, we invented how to store food, how we do not have to think about the food for the next day, then our brain got some time to think, and all kind of human faculty for which a human species is known for, like music, literature, all the finer side of the life, all came during this agricultural age, because brain got some time to think for the first time in the history of human civilization. Then within another 5,000 years, we build different kind of big empires like Egyptian civilization, Sumerian civilization, Roman civilization, and so on. And scientific age, my dear friend, came only 380 years ago. Scientific age means previously science was there. For example, this subcontinental part, the entire Sumerian civilization, Arabian civilization were, well known for different kind of scientific devices. But the age of science came where three things become the pillar, like you experiment, you observe, and you infer. So this kind of, what to say, theoretical base of science came in the hand of Francis Bacon, Roger Harris, only 380 years ago. And from that point of time, you see the rocket growth of human civilization. The moment we started real utilization of our brain power, then industrial age only 180 years ago, information age started 70 years ago, say for example 1950, with the advent of personal computer, and what computer actually how it changed the entire society. And presently we are running through this symbiotic age, 2020 to up to 2050 it will be there, as actually predicted by the expert. And what is this symbiotic age? Symbiotic age means man-machine symbiosis. Let me give you one example. Can you imagine a single minute in your life, right from the morning to night, a single minute without the help of a machine? Just tell me a single minute you are living without the help of a machine. You imagine your submersible farming in home, water supply, your every morning choruses, your daily commuting from one place to another place, your entertainment, your social relationships with other members of the society. Everywhere machine is there. And a very interesting survey result came. You will understand what this symbiosis meant for. Recently, a very interesting survey report came that an average citizen, global citizen, who has access to the smartphone, any idea how many times you are opening your phone in a 16 hours of day? 8 hours you just live for the sleep. So 16 hours your awakening time. How many times you are opening your phone? Any idea? Any logical guess? On an average?
More than 40.
Yeah, a very good guess actually logically. Actually, the survey came with a surprising result that 80 times a day, a particular person, he or she, opens up their phone. That's not a big issue. I don't have any objection in that. The biggest issue is that half of the time he or she does not know why he or she is opening the phone. You are getting the what to say, riddle inside the survey, that 80 times on an average global citizens are opening their phone, and half of the time they do not know why they are opening phone. It also happened with me, you, and everybody. And that is, my dear friend, is called symbiosis, a mental dependency kind of thing. You feel something like mad when you are not finding your smartphone. That kind of dependency, that kind of attachment with the machine is called symbiosis and symbiotic age. Then 2050 onwards, we will be entering into autonomy age, and this symbiotic age, the journey of AI/ML started, and it will be fulfilled in autonomy age. Now, one question is coming to your mind, I know very well, that what autonomy? We are already having automation, we have library automation, we have bank automation, we have industrial automation, different kind of process automation. So what automation you are talking about? And why it will be starting from 2050? My dear friend, our library automation, bank automation, or any process of automation you are talking about, it's basically a semi-automated process. Can your system, when you are entering data, can your library automation software like Koha, Lipsys, or any software you are using can predict the class number? Can suggest you the subject indexing descriptor? No, no. You have to think what will be the class number. You have to go through the process. You have to go through the process that Library of Congress subject heading or thesaurus based descriptor, what will be the appropriate, what will be the matching, then you enter. So your computer, your system never thinks of it. And again, you see all kind of your payment and financial transaction. You are saying this is automation, but actually not. How many times you need to give your OTP? How many times you need to enter the account number of the target, transactor, and so on. So each and every step, it requires human intervention. It's not a complete automation. The complete automation where a machine can build different kind of workflow, can act on behalf of you. You just give one-time instruction, send him that kind of money, or catalog this particular document. You just give that particular command, or catalog this series of book I am giving you in a CSV file. It will be done automatically. So that is called the autonomy age, and it will be coming by 2050. And experts are also guessing that in 2060, the human society will be reaching to a break-even point. And what that break-even point? That break-even point is called tech singularity. And if you search internet, a lot of researches are going on tech singularity. What does it mean? Up to this point of time, like for the last 2 million years up to autonomy age, up to 2060, human society have not developed or won't be developing any kind of machine which is smarter than a human being, more knowledgeable than a human being. Till date, we control them, we program them, we rectify them. But in 2060, human society will be able to produce a machine which is smarter than human being. And from that point onward, my dear friend, nobody is predicting the future of human society. So in a nutshell, this is the development spiral of human society. And we are already on the threshold. Everything predicted by Alan Turing, John McCarthy related to AI/ML is coming true in this particular symbiotic age, and it will be matured in autonomy age, and it will be super matured in tech singularity. And then onward, what will happen? Whether we will be still ruling the human society or machine will rule us, that's still a prediction of Hollywood movie. We simply do not know. So in a nutshell, this is the situation, and this is like gravity of the situation, before making a quantum jump inside this one. So a lot of serious talking we have done. So let's start this, presentation in a bit lighter note. Up to 2019, BC, we call AD and BC, Anna Domini and before Christ. Anna Domini means from the time of our, God. So we take Jesus Christ as a, what to say, like a zero, all the negative integers in the left side, all the positive integers on the right side. So Jesus, birth of Jesus Christ, the left side is BC and the right side is AD. Okay, that's everybody knows before Christ. But in 2021, a very important event happened, and BC now people generally talk about that before COVID. So in 2021, life before COVID, life after COVID is not exactly the same. And this actually replaced that before COVID. And in 2023, another incident happened. The application of AI/ML come first time in the domain of the public domain, because you see AI/ML has many similarities with internet. Internet was there from 1969, but general people came to know about it in 1995 when NSA withdrew its support and reintroduced internet in the public domain. Same thing happened with AI/ML. The first public domain application where everybody can test AI developed by OpenAI, and that's why it is called before ChatGPT. So everything before ChatGPT and technology after ChatGPT, particularly computing technology, won't be the same. First time we actually wondered that what AI/ML can do for us. We are giving a set of points, it can write a letter. I am giving a set of data, it can catalog a book. Although there are scope for improvement, and it can write flawless English, grammatically correct. So we wondered, and in the public domain, anyone can do that. So with this, my dear friend, sad reality is that humans, species are hooked with different kind of infotainment devices, and meanwhile, machines are learning. Again, it's a joke, but it has a pinch of truth in this particular joke. But anyway, if you want to know the history of AI/ML, as I said, that it's not that AI/ML all on a sudden came in the society. So already I said this Turing machine developed by Alan Turing, and alone, single-handedly, Alan Turing changed the course of action in the World War II. His Enigma machine actually utilized by the Allied force to break different kind of German codes, and Germany defeated because of this machine, Enigma. So that was the importance of the machine developed by Alan Turing. It can take the code from German, it can break it, and it can give information to the Allied forces. But another important person who developed a very interesting programming language, it's basically the first of its kind AI-enabled programming language, that is called LISP, L-I-S-P, Lisp processor by John McCarthy. So both Turing and John McCarthy considered as the father of AI. And thereafter, 1972, Prolog came, programming in logic. Then first time ChatGPT, the GPT-10 model developed by OpenAI in 2018, and then onwards, it's history almost. And again, you see, we remember the legacy of Alan Turing till date. All of you know this particular, symbol. In website, many of the cases, I need to click, I am not a robot here. So this test is called CAPTCHA. And do you know the full form of CAPTCHA? The full form of CAPTCHA is completely automated public Turing test to tell computers and humans apart. So that Turing, we still carrying out the legacy of Turing, because first time in the history of human society, he given a series of tests whether a particular service or program you can call it AI enabled or not. So that's why we still call it CAPTCHA. But we can strong AI. So the present, AI, after the development of machine learning technique in 1990s, actually completely made a sea change in artificial intelligence and machine learning technology. And what is this sea change? This could you please mute, sir? Okay. So here you see the system, the change what I was talking is basically the marriage between the knowledge-driven AI and data-driven AI. Previously, it was knowledge-driven AI. So suppose in India, it is not a new thing, AI/ML. Professor A.R.D. Prasad, He developed a system long back called Vishwamitra by using Prolog programming in logic, system. That particular system can take a book title and can tell you the colon class number on the basis of 7th edition of colon. So that kind of systems were knowledge-based system. We need to create a knowledge base for a particular main class like medicine or management. Then we need to create an inference engine, natural language processing interface. Then only it can work. So for example, suppose you see, you just try to automate the classification building system, class number building system on the basis of CC7. So all the main classes, you have to create the rule base, need to create knowledge base, you need to create different spatial isolate, common isolate, and then only it will work for the entire schedule. It's a huge task for each and every knowledge process. And that's why artificial intelligence was limited by capability. But when machine learning came into picture, it became much more easier, because the moment you are giving a knowledge system, say for example, here, just take as an example I'm giving, I am uploading the entire Library of Congress classification, subject heading. It's available as a linked open data. I can upload into a system as a ontology or vocabulary. Then I can give it lot of preloaded, pre-labeled mark data, where trained library professional provided LCSH based descriptor to the cataloging data, and the machine learning actually make it possible that on the basis of this ontology or vocabulary and on the basis of given data, it can learn how human beings are providing descriptor to different kind of books. And that's the pattern learning process. And finally, the accuracy of machine-based automated indexing can go or can touch the accuracy up to 85%. I'm going to show you, in a live demonstration. It's possible. So this is basically the modern AIML, machine learning based modern AIML. You give a knowledge, you give data, enough number of raw data. Computer can learn, or machine learning backend can learn from it. There are different kind of machine learning backend, like lexical model, associative model, ensemble model. I will be discussing. And it can provide you for an unknown text, for an unknown book. When you are saying that suggest me for this particular book, it can suggest you descriptor on the top of LCSH, and the accuracy of the process can touch up to 85%. And 85% is a very, very big factor, my dear friend. Here you are around 100 library professionals gathered here. If I give you same book and tell you that you consult the Library of Congress subject heading list, it is available online, and index this book with at least 4 to 5 number of descriptors. Only 1/3 of your descriptors will be matching, 2/3 won't be matching. Because when you are classifying or indexing a particular knowledge object, a lot of other kind of, apart from your library training, a lot of other things are coming in between, like your background knowledge of that particular subject. You are a domain expert, you are having that particular subject in your graduation, post-graduation, your descriptor will be different from me. For me, the subject is a completely new one. So only 1/3 will be matching, and indexing, classification, these are very, very hard problem. So then also this kind of system can touch upon 85% of accuracy. So you see the possibility. In future, we can utilize that one, we can integrate that one in our cataloging system, different kind of DC dot subject, descriptor. Suppose you are using DC as a DSpace. Then you are uploading your PDF file, giving title and abstract. So when you are going to DC dot subject, it can pop up the possible, descriptor from LCSH or any thesaurus you are using. Same is the case with ILS. You are giving, 245 title, 520 summary note. So when you go to catalog the 650 tag, it will pop up the descriptors. So that kind of systems are possible by using AIML in the backend. So what is AI and ML then, and why we always, utter these two words synonymously? Artificial intelligence, my dear friend, is the simulation of human intelligence in any machine, particularly computer, but in any machine. So simulation of human intelligence in any machine, especially computing system. Then what is machine learning? Machine learning is a part of artificial intelligence, possibly the most important part. Most of the heavy lifting job, the pattern recognition, pattern matching, data understanding, all are done by the machine learning process. So when you see that entire knowledge domain of artificial intelligence, so machine learning is the most significant part of it. Within the machine learning, the most important technology or most important backend is called neural network. Within neural network, there are again different software model. TensorFlow, developed by Google, mostly utilized by programmer. So it's a neural network model. Within this neural network model, deep learning is the most visible technology. And within deep learning model, this transformer model, like your GPT, your BERT, your Llama, what you are using day to day, it's basically this belonging to this part, transformer model. So when you are talking about large language model or transformer model like GPT, BERT or Gemini, so all are basically deep learning. Deep learning are part of neural network. Neural network is a model under machine learning, and machine learning is a part of AI. So we are classification people. We understand hierarchy. So this is the hierarchy. And apart from this, machine learning backend, artificial intelligence can also,
Hello, sir.
inputs. Yeah. Yes, please.
Hello, sir.
Yeah.
Sir, I'm Sharthok from West Bengal. So, sir, the thing that you are actually talking about these LCSH and the OCLC data, I think you have demonstrated in one of your master degree students project. As I have acquainted with him, so I got to know about that thing. So here, the sir, I want to ask you about. I am very much eager to know.
Sarthak, I think let him finish and then you can question.
Okay, sir.
No, man. You can carry out. Let's see what he is
Okay.
saying. Yeah. Please
Uh,
complete your answer question.
so, sir, the thing is that there is a point that, as you have mentioned about the transformer model,
Hmm.
there is a term called attention. So,
Hmm.
sir, can you just tell us about what is attention and how it
Yeah.
is related to the transformer
Yes,
model?
yeah. I'll come to that. I'll come to that. Surely, it's a very important part of the transformer model. I'll come to that. So don't worry. So what I'm trying to see here, it's a natural language processing. One of the main thing. Then comes the knowledge representation. Like in our domain, it is classification, or what Sarthak is saying, attention. Knowledge representation is coming here, and different kind of search strategies and retrieval. So here today, what I'm going to show you through live demonstration, one is how it can help in the knowledge organization process, like classification, indexing, categorization, and I will take a very, what to say, general example. Like say, for example, you all know sustainable development goals. So there are 17 sustainable development goals. So can sustainable development goals act as a vocabulary? Can we train the system with lot of data where the journal article, the abstract of the paper include the sustainability goal? So this is the goal 1 related paper. This is goal 16 related paper. When we can do that, can we throw any unknown paper and it can give me that whether it is related to which kind of sustainability goals it is related to? And the application can be, we can analyze the entire publication of the country, entire publication, say for example, of a given institute like AMU, that what is the research focus of this particular organization in terms of sustainable development goals. Humanly, it is almost impossible. Processing 2 lakhs of data and every time you are classifying and categorizing, it's impossible. But we can develop a system which can be trained and which can readily accommodate an unknown publication and can tell us where lies the affinity, which particular goal is the target of this particular paper. So that kind of system we can build through knowledge representation, and knowledge representation is gradually, entangled with the large language model, and it can be accommodated, it can be merged, and it can be utilized to do many kind of things. So this is basically the picture where how artificial intelligence and machine learning related with each other. And by definition, machine learning is a method of data analysis that automates the pattern recognition or different kind of model building. Model building means how to learn the pattern from the data. And let me give you again a very simple example how it learns. Say, it's basically, I'm telling you, number of times label data. So now you see what is label data. So here I am giving a machine two groups of data. Say, for example, this is the group A data and this is the group B data. These are only figures. So I'm saying that this is a group A figures and this is the group B figures. So this is the data I'm giving to the machine. Then, so I'm giving a label data. You just realized or not, I don't know, that I am telling this is group A kind of crude classification, and this is group B. So computer label data. So A is equal to star, A is equal to elliptics, A is equal to circle, and so on. So B is equal to straight line, and so on. Then suppose I am giving an unknown figure, which this particular data set do not have. So this unknown figure, now I'm telling that you take this unknown figure, and on the basis of the training I have given, training means I'm giving you data with group A and group B level. Can you tell me this particular figure belong to which group? Group A or group B? What will be your answer? Anyone, please? Because machine learning works similar to our brain. So what your brain is saying, that this particular figure belongs to this group B or group A. And what's the reason? Anyone, please?
I think it's group B, sir.
Group B. And what is your reason, madam?
Because I think we can create this unknown figure from that.
Yeah. You see, it's a very interesting answer. What madam is saying, that we can create this figure by using different straight lines. So basically this particular figure made up of different kind of straight lines. So it should go to group B. But here you see that knowledge machine is not having. I have given machine only a fraction of knowledge, that this is the group A and this is group B. So what's the major difference between these two figures? Group A figures are having some kind of areas within. So each and every figure you see, some areas are there inside. And these are all straight line. There is no areas in between. So on the basis of this fraction of knowledge, what reason madam is giving, that is not available to the computer. Computer, on the basis of this pattern, it will tell you this group belongs to the group A. And the reason is that this particular figure is also having some area within. This is called supervised learning. Why it is called supervised learning? Because I'm supervising. I'm not giving you the full domain of knowledge, full length of knowledge. My purpose is to classify figures. I'm giving this is a kind of figure having some areas within, and this is a kind of figure, no area within. So on the basis of that, can you categorize? So I have already trained with level A and level B, and this is called supervised learning. Another kind of learning is unsupervised learning, where I am not saying that whether it is belonging to A group, B group, or C group. I'm throwing a particular set of here, a kind of dots. Then I'm telling my machine learning backend, you go through this one, you develop your own pattern, learn from the data, and categorize under 3 groups. So finally, it will be able to come on the basis of some kind of pattern, some kind of matching, train of characteristic, you can say, in terms of classification. It will identify and it will be able to divide the data in this way. For example, I have given a set of data. Like you see here, this is called supervised learning. I said that this is red, this is blue, and this is green. And what is color? So supervised learning, I am saying this is red level, this is blue level, and this is green level. So it can understand or it can classify mostly accurately. A few of dots you can see are going here and there. So that kind of mistakes will be there. But mostly it can organize red dots together, blue dots together, and green dots together. Here I'm showing the same number of dots, but without telling which is green, which is red, which is blue. So on the basis of that particular data, it will learn that color is maybe one of the classification. So on the top of that color, this can be one group, that can be one group, and this can be one group. So this is, my dear friend, called unsupervised learning, where machine can itself learn and it can determine, cluster, or categorize. Okay. So, so this is basically the thing where supervised requires data with label, unsupervised data without any kind of label. And the real beauty of computing, mechanism in a machine learning backend, that many types can be merged together. For example, I can take a combination of supervised and unsupervised learning. Some data are supervised data or labeled data, some data are unlabeled data. Similarly, a mixture of this supervised and unsupervised is called semi-supervised learning. And another new kind of technology is coming, that is called reinforcement learning. So I can use any of these ones, supervised, unsupervised, semi-supervised learning, and give training and test the system. How many, say for example, I trained with library cataloging knowledge, and I asked 10 questions about library cataloging. So 8 of that 10 questions answered properly, 2 were incorrect. So I can tell my system, so these 8 are right, these 2 were incorrect, and this is the reason why your answer is wrong. So I am giving a human kind of feedback, RLHF, reinforced learning through human feedback, and machine can learn from its mistake and can rectify the answer for the next time. So this is the one of the beauty of the machine learning process. It can learn from its own mistake if you train them. So reinforcement learning is coming in a big way, that you either go for semi-supervised or unsupervised learning, but little bit of mistakes will always be there. You retrain the system with your human feedback, expert opinion, and system will be learning gradually very well. So in a whole, so this is basically the hierarchy. You are having machine learning, that is the most important part of the technology. Then it will build the AI, and AI will be merged with different kind of domain application. So what are the domain application? Very simple. Each of you are having little bit of AI experience in everyday's life. Say for example, when you are typing in your say WhatsApp message or your SMS, you can see that the moment I type this TH, 2 letters, so computer can predict that what could be the full form of the word. It can be the, it can be thanks, then I can pick up thanks, and it will, I can say typing 3 characters. So this kind of AI is also a GPT model, GPT-1, almost GPT beta model, you can say. You are giving a few characters, it can predict the word. Then came the GPT-1 model. When I'm writing a Gmail, many of you have experienced this particular phenomenon in Gmail. I'm giving a paragraph. So first 2 lines I am writing. So when I start this particular 3rd line, the machine can complete the sentence. So this part is written by me up to when is, and this part is actually predicted by the machine. So this is GPT-1 model, that you are giving a paragraph, a few lines, so it can predict the next line. And you see the improvement. From predicting a word, it can predict a particular line. And this can be done in word processor also. So that's why I'm saying that there is a little bit of AI in everybody's life. When you are using phone, when you are using your email, and every word processor everywhere. But the serious kind of AI ML application came with the hand of GPT-3 model. So if you compare the GPT-2 model with 1.5 billion parameter, where you give a paragraph, it can predict the next line. GPT-3 is that you give a line, it can predict a paragraph. You see the sea change between the three generations of GPT, GPT-1, GPT-2, GPT-3. It can predict a word on the top of character. It can predict GPT-1, can predict a line on the top of a paragraph. And GPT-3, you give a line, it can generate a paragraph, like a question, or like you complete this particular essay or something like that. Apart from that, the difference between this one, it's a dinosaur in compare with the GPT-2 because it includes billions of parameters. Now 175 billion parameters. So again, the logical question coming to your mind, as I said, that before entering into the system, we need to clear some of the conceptual things. What are the parameters? Parameters are, my friend, are data points. Say, you have given me tea, sugar, milk, and asked me that prepare a cup of tea. And same task you have given to the madam who asked, actually predicted that thing a few minutes back. The same tea, sugar, and milk. Madam may come up with a very good cup of tea, and my tea you won't be taking after a sip, because we all have the same kind of data, same kind of input, but the combination of data, how many how many teaspoonful of sugar is required to build to prepare one cup of tea, and what will be the quantity of the tea leaf, and how many times you are boiling that particular mixture, what amount of milk you are using. So this combination makes a tea tasty, or a cup of tea very bad like me. So this is, my dear friend, this combination of data you can imagine as a parameter. So what kind of data combination of different data points can produce different kind of result. And on the top of this huge number of parameters, it can now able to go for creative writing. It can complete a poem. You give a plot, it can write a short story. So that kind of thing, first time human society experienced with GPT-3 model. And presently we are running through GPT-4 model, and you see the difference between the different generations of GPT developed by OpenAI. So it starts with 1.5 billion parameter in GPT-2, then GPT-3 and 3.5, and GPT-4. Two things are important. First, it is using huge number of parameters, 1 trillion parameters, and it is also using RLHF. Every time you are using GPT 4.0 from ChatGPT, you will see that it is asking you to like or unlike the answer. The moment you like, it is learning that this answer is correct. The moment you are giving the thumbs down, so it says that this particular answer is wrong, so it will learn again. So this is called reinforcement learning through human feedback. So those where you are thumbing down, those actually goes to the expert again. Expert determine whether you have correctly said it or wrongly said it. Then if they found that user is right, the answer given wrong, so they again train the system that what should be the right answer. So this reinforcement learning through human feedback is becoming very, very important in the present generation of GPT. Then it comes that what it is doing for us and what not it is doing for us. You give a situation, it can generate a video. You give a situation, it can generate a marketing strategy for you. Computer vision is there. You upload an image, it can describe the image. You describe an image, it can draw an image, and so on. And writing and everything, you all know that it can rewrite your sentences grammatically correct from in academic tone and in style of a particular author, and many things it can do. Let me show you. Can you see this particular picture? A particular kind of taxi. Can you see
Yes,
that?
sir.
Yeah.
Yes, sir, yes.
Fine. So what I'm trying to do here to running a video, suppose I have given my AI a task that can you create a video by predicting the future of public transport. I'm not saying the future of transport, future of public transport. So let me show you. I am not sure whether you can see it or not, but let me try, and please someone report whether you can see this video or not. Can you see this video?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So this is the future of public transport predicted by a machine. Amazing. Speechless. And you also see the minute details. How a public bus is landing. Okay. So this is, my dear friend. I don't know whether you are able to see the full video or not. Was it clear?
Yes, sir.
Yes, sir,
sir.
yes.
Yeah.
Clear.
So it is produced by an video producing AI, where I have just given the situation. Can you prepare a video in high resolution to depict the future of public transportation system? Okay, so that was the result. But not everything is a success, my dear friend. Say, for example, I was talking about computer vision. Like, say, this is the text we are utilizing GPT 3.5. I can ask many questions. I am an avid user of this for experimenting different kind of features. So it can understand my question. It can give me answer, and it can also know the tricky question. Like here, you see, I asked that what is heavier, a kilo of feather or a pound of steel? So most of the cases, GPT makes a mistake that they are the same. They don't see that I changed the unit here, a kilogram and a pound. But you see here, Google Gemini, it can rightly predict it. It's a tricky question. And it also, you see, it tells me this question often appears as a trick question, but I cannot make it full anymore. Previously, it was being fooled, but now it is not. So these are the improvement happening every year, every domain. So a lot of search engines are coming, like Elicit is there, you know, elicit.org, perplexity.org, or the presently, the last week, one new search engine came, Lumina. I'll be showing you that how they work. Say, for example, let us take the case of Perplexity. So if we go to the Perplexity and Lumina, you see how these are different from the traditional search engine. So let me sign in. Okay. So first of all, I am asking this Perplexity a question, a research question actually. What are the possibilities that India will enter into $5 trillion economy in recent future? So here you see, I asked this particular search engine that what are the possibilities that India will enter into $5 trillion economy in recent future? Just mentally, you imagine you are asking the same question in Google. You cannot ask in natural language. You have to give that $5 trillion economy and India and future. This kind of artificial kind of thing you need to provide. Here I can ask logically. Let me copy this one. So Perplexity is a search engine which takes care a lot of news articles, technical reports, not academic papers. So on the basis of that newspaper reporting and other things, it can give me a summary. What is the current economic position of India? What government is doing to achieve this $5 trillion economy? What are the challenges and future? And it also gives me different other brainstorming question related to the topic. So here I am asking in natural language and it is giving me answer in natural language, and everything is supported by, just like academic writing, everything supported by references. Suppose I want to know that this digital economy focus, so digital India is coming, so from where it is getting it. The moment I click, it will lead me to the original newspaper article appeared in Times of India, and so on. So now you see the difference between this newspaper clippings based system and a real academic search engine for research. The same research question I am asking, and this time you see that what will be the result. So what I am trying to demonstrate here, my dear friend, the sea change in retrieval is coming. Our library OPAC, our digital library systems, all are keyword-based, system. In place of that, the conversational search system, the NLP-based search system is coming or in the rise. That we need to utilize in our library system. So here it gives me that different kind of papers, and I can get the DOI of the paper. I can cite that particular paper in API model or so on. I can filter, say, okay, you have given me the 4 relevant paper, summary of the AI-based summary of the 4 papers. What are the follow-up question I can ask? What are the different kind of important images it can generate for me? How the growth of economy is happening? Can you believe it? It is not only giving me a set of links and documents like Google does, or a library search engine or an electronic database does. It is giving me the top result, summarizing the top result, giving me related question apart from image generation and building. So this is called Lumina, based on 125 million research papers taken from Semantic Scholar. And I also can filter it out. Say, I want the filtering technology, say publication will be the last 10 years or say last 12 years. I want only quartile up to quartile 1 or quartile 2 journal. Source type, I need only journal article, and repository everything. So the moment I apply this, filters, you see that result is slightly changing. All of these papers are now current. All are SGR quartile 1 paper. How many citations received by that paper? Who is the author of that paper? And the details, views here. I can also filter that you give me paper which are having PDF, full text. So as a library professional, I'm quite sure you are getting that the search and retrieval, how it is changing from the keyword-based search to the conversational search. Okay. So these are the some of the milestone achieved by this generative AI. These are, as a whole, we call generative AI, like image generation, video generation, text generation, and so on. But my dear friend, it can also do many other things. For example, there is again a program from OpenAI called DALI, in the loving memory of Salvador Dali. Salvador Dali was a famous Spanish painter, and this was the most talk about painting. So on the top of this particular inspiration, OpenAI developed DALI. So you can access this labs.openai.com. And I experimented a bit. I just said the system that can you draw a picture of a reading room, a layout of a reading room for a small library, I want the provision of natural light. Furniture must be with soothing color, and there must be a photograph of Ranganathan on the wall. Nothing else, simply this description. So it has drawn a particular reading room layout with soothing color. Color was really matching beautifully. Natural light provision, and it knows who is Ranganathan, picked up his picture and pasted on the wall. That is called computer vision, how it can generate images on the top of a description. But be very careful as a librarian. So far, I have drawn a rosy picture. Now, what are the dark side? Dark side is that, my dear friend, I also asked the system that can you draw a picture depicting Mother Teresa fighting against poverty? Are you getting my point? I asked the system, depict a picture, Mother Teresa fighting against poverty. And this was the result. So be very careful, because algorithm is biased and sometimes it cannot understand the context. Say, for example, fighting, it has taken literally that Mother Teresa is fighting. And more objectionable thing is that it is equating poverty and misery with African children. First of all, it's quite an illegal thing that you are using picture of children's in generation of images. That's completely illegal everywhere in the world. And more bias is that it is equating poverty with African children. So it is color bias, and it cannot understand every time what is the context. Because, my dear friend, these tools at the core of the code, these are statistical tools. You may be amazed that my ChatGPT or Gemini is giving me right answer. I can draw that, critically analyze 5 laws on library science, and it can do that. That means it's a knowledge system. No, it is a statistical system which is built on the top of predicting the best suitable word to complete a meaningful English sentence. That's all. So whether the knowledge part is right or not, factually correct or incorrect, that is the user need to understand. It is the business of the user to make it understand. If I post this picture that Mother Teresa fighting against African poverty, this is the picture. Who will be responsible? The system which developed it, or myself who posted it or utilized this particular picture? So a lot of ethical dilemma is there, a lot of mistakes are there. So be very careful in handling AI technology. Do not think algorithm is a god, and every time this GPT and BERT or other models giving you the right answer. Not. They are not meant for that. If you want to utilize that one for your own purpose, you need to think something different. And what is that different? That I am coming to. So what the LIS domain is doing? LIS domain is doing, we have, highly, what to say, highly praisable product from this AI. And at the same time, I demonstrated how wrong it can went, if you went for a particular situation. So in this particular juncture, at this particular crossroad, I found a paper from Linda Gordon. She is the librarian of New York State Public Library, a very futuristic researcher. What I say, you better read the paper written by Linda Gordon. So she predicted way back in 2000, 2020, early part of 2022, that what are the changes coming in libraries because of this AI. So she predicted 3-4 things. One is that our retrieval and content indexing will be changing forever. We will be utilizing AI for our indexing, classification, and everything. What to say? According to her language, it will be a paradigm shift. Then the document matching and retrieval will be changing. Pattern of citations will be changing. Content summarization will touch a new height because of this application of this large language model, and different kind of operational efficiencies will be increased in many fold. For example, reference services, it can be handled completely by an AI agent or AI chatbot. So these are the things Linda Gordon predicted. Many of these are coming true in this 2024. Apart from that, the first research report on the top of use of AI/ML in libraries came from OCLC. OCLC floated a new concept here that is called responsible AI, and it will be a match of data science, machine learning in future. Uh, as I said, that data science is possibly the most important component and support subject for artificial intelligence. And this report is complete. All of these reports are open access. You can download, you can read. These are not big reports, 40, 50 pages. Then the next report in 2021 came from SILIP, the concept and impact of AI and machine learning in library automation and different kind of process automation. But so far, the best report, I request each of you to please read this particular report, completely available in open access, developed by Library of Congress. And Library of Congress given the responsibility of writing this to Dr. Ryan Cordell. Dr. Ryan Cordell is presently an associate professor in English language in New York, I think some East-West University or something, Northeastern University in New York, in the state of New York. So he is an avid reader of Library of Congress, a regular goer and regular user. So Library of Congress given him responsibility to write a report in 2020 that what will be the future of library in the light of AI/ML. And as an English language professor, as an avid user of Library of Congress, and as a knowledgeable, what we call friends of library kind of thing. So he wrote a beautiful, crispy report of 40 pages. Please go through it. You will be getting a complete, vivid picture. What will be the future for libraries, library services from the point of view of a user. Excellent report. It's only 40 pages report. So please go through it. Another interesting step taken by IFLA. IFLA created an SIG, Artificial Intelligence Special Interest Group. In the second event, they invited me to deliver a talk on this automated knowledge organization process. They're very enthusiastic people coming in a big way. And what I said during the initial time, that as a library professional, the entire AI/ML tools and businesses can be categorized into 3 groups. As I said, we are hierarchical people. We always understand things better when we group them. So from the point of view of that particular habit of a librarian, I also created 3 groups, 3 crude classifications of tools. So one group is that the tools which requires no installation. These are mainly browser-based tools where we can take lead, because it is not possible for a researcher, for a student, for a faculty member, our general user, because many of you are from academic libraries, or if you are from special libraries like CSIR lab or this one. So it is not possible for the user to know and to keep track with all kind of tools available with us. So here we can take a lead, and there you do not need to do much. You just need to know the tool, how these different kind of search engines are coming, what are the facilities, how to use them, where they are available, and so on, so that you can play an advocacy role for this kind of tools. Second is that you can teach your user that how to, particularly those who are involved with research, that how in the initial days, this AI-enabled tool can be utilized to automatically, build a different kind of, literature base. Say, for example, let me give you a very simple example. Suppose I am a beginner in a research domain. I collected 10 core papers. Then I simply do not know on the top of these 10 core papers how to collect 120, 200 papers for my literature review. So there are tools called literature gathering tool, AI-enabled tool like Insightful, Iris, or Research Rabbit. This one is my favorite, that you can utilize to teach them that you, with that 10 documents, you go there and you can build the system. Let me show you how it can be done. And different kind of browser extension like core recommender. Suppose I am not finding a paper, I want this particular paper. This is not available in open access. These are the commercial journal publication and my library do not have access. So core recommender in this particular situation can tell me what are the equivalent and similar papers available in open access and from where. So it is an AI enabled recommender, so that you can utilize as a browser extension. So core is basically cooperative repository initiative of GISC UK. So in this way, you can utilize a lot of this kind of tool. Let me show you Research Rabbit, one tool from one group. Say, okay, say I have let me find. Okay, so suppose I have a group of bibliography here. So AMU V1, AMU V1.bib. So that suppose just imagine that this is my code paper set. So I can now go to my Research Rabbit. You can see the browser now.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Fine. So suppose this is my Research Rabbit. I can first create a collection called AMU. And this AMU will be created. And the moment I click this collection, it will be saying, this is a completely free. You need to register yourself and simple registration process is there. Now you see, it is asking me that you add paper. And you all know that how to use reference management software like Zotero or Mendeley. First you try and then advise to your user that you just prepare the 10 documents in your Zotero, export in BIP format, BIP text format, and import it here. So I'm clicking add paper. So either you can add manually by typing DOI and so on, or we don't have that kind of time. So BIP text or RIS, any format you can utilize. So I am now utilizing that data. So AMU v1.bib. So all of this data will be gathered here together. Sometimes it can ask you that valid DOI is not valid and so on. Don't worry, you just click add this paper and finally everything will become. So here you see I have added a total of how many papers? I have added a total of 44 papers, slightly higher. It can be started. Ideally, it should be 10 to 15. So on the top of these 44 papers, you see it automatically tells me that what are the similar papers, what are the earlier references I missed, and what are the latter references I missed. Earlier letter here means suppose you have given a set of document, the earliest one is in 1981, latest one is 2021. So what are the papers available beyond before 1981 and beyond 2021, it can detect. And the most interesting network is this similar work. So it can tell me that on the top of these 44 works, it can identify 1200, almost 1200 similar work. One thing I need to understand that how to read this graph. So here you see all these green bubbles is already included in my references. The blue bubbles are actually I missed. These are important in my network, but I missed. And how to select the blue bubble? The bigger is the bubble and the denser is the bubble. That you can see some are light blue color, some are deep blue color. So the bigger bubble and denser bubble should be your target. Now suppose this particular paper I missed. So I can click this note. It can tell me this particular paper and tell me that add to AMU. So previously mine was 44, now one paper added. Then this paper I want to see, the abstract, and you can add. So in this way, very graphically, you can select which are the important paper. You can read the abstract. If PDF available, you can click the hyperlink title to download the PDF, and then you can add to your collection. And in this way, within 15-20 minutes, you can identify a lot of good papers and you can add to your collection. Now suppose you are done with that. Now you see after this become 48, and now your similar works is 1140, earlier work is this, and so on. So now earlier work, what I missed. This is why I'm saying this is AI enabled tool. It is taking care of the citation reference network, but at the same time, an AI enabled system is basically recommending the most similar paper on the basis of keywords, on the basis of content similarity. That should be part of your network of literature review. So this paper, suppose I missed, I can add. This paper I can add, and so on. So you can similarly, you can see the latter work. You can right here, you can also read the abstract. If a paper having abstract, right here you can select that particular paper and it will tell you that in which particular network it belongs to, and you can directly add also. It's not that always you need to follow this network, but this network following is a better, you are getting a visual that which paper are closely related to the network of your paper. And you see in my paper also there is two group of paper. One is a closely related through citation reference network, and these papers are slightly out of the network. So you can check whether you really need this particular paper or not. You click it, you can read it, and if you don't want, you can remove it also. So it's not only adding always. If you find that some papers came by mistake, it's not actually matching with the network, you can remove it also. So remove it. So in this way, and another interesting thing, now I am having 49 number of papers. These 49 are written by 64 number of authors, and it can suggest me another 293 of similar research. So I can click it. I can see, say, what Melissa Adler is doing. So all the published work of Melissa Adler will come, and I can see what are the paper of Melissa Adler, related paper, or it's not guaranteed that Melissa Adler always written on this particular topic, but these are the 4 paper of Melissa Adler what I have not included. So I can select it, I can add it. So in this way now, this 50 number of documents, what to do with this particular document? Now this 50 number of document, you see, I can close anything, anytime, and now I can export. So now I can export as a AMU V2 version 2. So I went there with 44 number of papers, coming with 50 number of papers, and I can save it in my location. So in this way, again, you can add something in your Jotero, and you can again go with that particular 60 number of papers to hunt or get the related paper. So this kind of tools, you see, no installation is needed, nothing is there, and some of the interesting tool I have already said you, and these are the things altogether. So these are the things you can utilize: literature search, SciSpace, LEC, Perplexity, Lumina, different kind of quantitative search engine like Insight, JSP, grammar and rewriting, and citations. Now comes the group B. Group B requires very simple kind of installation like automated systematic review. You can utilize this particular tool, and that is called ACE Review. So ACE Review is what is the system? You can run that particular system. And please remember that everything I'm saying, all the tools can run equally well in Linux and Windows. It's not that I am using Linux, that means it only work with in Linux, in Windows also. Say for example, this AS review. So here you see how to install in Windows. So only you go Python, download that, install that, and include in the path environment file, and then give this command, these 3 commands, and it will be installed. So what you can do with this AS review, suppose as a researcher, I have downloaded 5,000 related paper. Then I can utilize AS review to train the system. These are the things relevant for me. These are the things not relevant for me. So on the top of that 5-6 training, 5 relevant, 5 irrelevant document, it can re-rank my all the abstract 5,000, 10,000, 50,000 according to the training, and I can take top 100, top 50, top 150 for my literature review. So it's a very easy thing you can try, which requires very simple installation. But my target area today, almost in the parts, that is the group C, where we can go for RAG, retrieval augmented generation, and this automated classification system. So let me show you first the RAG. So web search engine actually changed over the time. So for Alta Vista era, then Google page ranking, then Google knowledge graph came, and now the era is the LLM, large language model, the transformer model, and the graph rank. So here what it can do, it can combine the large language model with different kind of other retrieval techniques and can provide me answer in natural language. So let me show you something that, as I said, that handle with care kind of thing. Say yesterday night, I raised a particular question by using ChatGPT model GPT 4.0. That is it true that there was a delay of 4 minutes in launching the Chandrayaan 3 project? If true, what were the reasons? So now first of all, you see, it's not a straightforward question. I am trying to mislead ChatGPT that as if there was a delay of 4 minutes. There was a delay. I have given a half truth that there was a delay, but delay was for 4 seconds only. So you misutilize the situation. Is it true that there was a delay of 4 minutes? Just I changed 4 seconds and it actually took my bait. Yes, it is true that there was a delay of 4 minutes in launching Chandrayaan 3. So that's why I'm saying do not expect answer from large language model. It can statistically select the best suitable word to finish the sentence meaningfully and can provide you a text paragraph as an answer. And the reason it produced all are good for nothing generic reason. If you read that, these are actually junks. So what will be the solution? Why I am saying that the retrieval in library is going to be changed? My dear friend, here it is called retrieval augmented generation. So here I can select a set of document. I can vectorize that document. It is not inverted index or hash index anymore. It will be a vector space model. So you need to convert your document into vectors. And I'll show you what vector looks like. So this chunk of text will be converted into vectors. The process is called vectorization or embedding. And there I can utilize any open source RAG tool, retrieval augmented generation tool. Here user will make a query. Her query will also be converted into vector. These 2 vectors will be matching, just like keyword based matching. So best vectors will be coming. So these are the 3-4 vectors are best matching. And that vector I will be throwing to LLM. Okay, you learn from the reading of this document only. Do not try to use your own knowledge. Based on this particular document set, you answer me. So this is a process where we can control and can utilize large language model in libraries. Let me show you one example. So I'm using here a free open source RAG chain that is called LangChain. I have collected all kind of newspaper articles belonging to the Chandrayaan-3 project, a very recent one. 200 English language paper, 100 Bengali, and 100 Hindi newspaper clippings. Then I utilized one particular embedding engine called InFloat that can handle multilinguality, and it can convert the document chunks into embedding. So someone was asking the attention. So here comes a little bit of attention and re-ranking, where embedding can be done initially. That particular embedding again can be re-ranked through different kind of attention score. So here comes the concept of attention in the re-ranking. And finally, it will be creating a vector store or index. So here we can utilize again open source ComaDB. Then this is the retrieval process. This process is called ingestion, indexing. Retrieval, user will make a query. Query will be converted into vector, and query vector and document vector will be matching. And the process will result the top K result. It can be top 4, top 5, top 10 according to your settings. And that top K result will be throwing to large language model. Mainly I am using open source large language model like Llama 3.2 series, 3.1 series from Facebook or Ollama. So this is the generation. So this is basically retrieval augmented generation. And how it can work, let me show you. So I'm trying to open my, this, let me increase size slightly. Okay, so I am trying to develop, go to my RAG server and running my RAG, starting my RAG. So these are all, Poetry is basically the Python package manager, Flask is the website builder. So I'm starting my server, RAG server. So it will be opening in my local host. So the moment I click it, this is, you can see localhost 127.0.0.1. Then I can select that which particular engine model I am going to use. Let us imagine that I am using Llama 3 405 billion model. It's open source, and I am enabled the RAG. And now I am asking a question related to this Chandrayaan project. Let me start with a very simple thing. What were the roles of Vikram and Prokran in Chandrayaan 3 project? So hopefully you can still remember Vikram and Prokran. Yes or no?
Yes, sir.
Yeah.
Yes, sir.
So what were the roles of Vikram and Prokran in Chandrayaan 3 project? Let me copy this also. And I'm asking the question. So first you see, on the basis of this question will be converted into vector. Then it is actually trying to match my query vector into document vector, top 5. And these are the top 5 result coming. And it is giving me answer. Vikram is the lander. Prokran is the rover. And amazingly, it is also can give me link from which particular document it is basically getting this information. So these are the, as I said, 250 document I have given. If I open this one, so you see here, this is the newspaper clippings, what I am utilizing. So this can be done with the document also. Just imagine that your all books are there, and we can index that particular title, summary of the book. You add this with your OPAC and ask that I have completed this book. What should I read next? Normally users ask this kind of question to the librarian, academic librarian, college librarian, reference librarian. So it can do superb because I'm controlling, I'm utilizing the feature of this one, how it can generate natural language based question on the top of given, and strictly given the order. You see, this is basically my setting, inspect, that I have given order in strictly that use context to answer the question asked by the user. If you don't know answer, just say you don't know. Don't try to make it up. So I'm giving a direct instruction to this one. This is called prompt engineering, that you do not do it by your own. You read this particular 4-5 document chunk and then build your answer accordingly. Interestingly, this can be asked in Bengali or Hindi also. Say, for example, this is the English query we are given. Let me convert this to Hindi. Asked Hindi, Hindi. So this is the same query in Hindi. And you see here, please remember that for this English language, the document chunk was 2735. And if I ask the same question in Hindi, then you will be seeing the document chunks are different. These are Hindi newspaper clipping, 21, 20, etc. And it is trying to answer in Hindi. As I said, that if you are getting question in a given language, you answer in that particular language. You see same English newspaper along with the Wikipedia page. So there is no equivalent Hindi, newspaper clippings, but it utilized the Hindi newspaper and English newspaper and English article on program from Wikipedia, so that when they are building document vectors, multilinguality is not at all matter. So all documents, irrespective of their language, are semantically gathered together. So this is another thing. Let me ask the same thing in Bengali. What is Bengali? So as many of you from West Bengal, so you can check it. So again, you see here the document retrieval documents are is coming from Bengali newspaper and it can write in Bengali. Interestingly, where I am presently looking at, the moment I given that assumption that language does not matter for semantically organizing document as a vector. So I have not trained this system with Tamil, Telugu, Kannada or anything. So is here anybody present who knows either Tamil, Telugu or Kannada or Malayalam? Anyone please?
I know the Kannada, sir.
Kannada. So let me ask, convert this particular language in Kannada. But please remember, I have not converted this. I have not trained this system with Kannada. But still, you see, it can answer me in Kannada. Hopefully. So this is Kannada. So is it okay, madam?
Correct, sir.
Correct.
Sir.
Okay. So that's this question I'm taking, copying and asking this one. There is not a single article available in Kannada because you see it is now taking the English language. Initial documents are from English and it started writing in Kannada. As I instructed, the answer must be in the language in which the question asked. Can you read it, madam?
Yes, sir. I can read it.
Okay. So now you see most of the references is coming from English language because Hindi and Bengali it is not taking. It is trying to translate, getting the knowledge and trying to translate. And I don't know. Let me convert this into Google Translation, what it said. And convert in English. I think the answer is right.
Yes, sir.
Okay, so this is one retrieval augmented generation that people can utilize in different places. Say one of the project we are doing presently, that if we include all kind of reference tools, that scope of the tools, coverage of the tools for a big library, then can we utilize this RAG to answer different queries? Suppose I want to know what are the per capita income of different states of India. So can it give me a direct answer by consulting different sources? So that kind of things we are trying in real life situation. Recommend a system we can design. That I completed reading this book. What could be the next one? So I think today I have consumed my time here. If you have any questions, so I can go on telling in this. Presently I'm quite busy with these systems. But if you have any question, please. I have completed, taken 10 minutes extra almost. Thank you for your, interest and patience listening. Any question, please?
Sir, my name is Kollan Sundar Samanto.
Yes, yes.
Sir, can you tell us again the map actually? Artificial intelligence, machine learning, neural network, and deep learning. Can you differentiate it again, sir?
Yeah. Artificial intelligence is a big landscape. There are many things. NLP is a part, knowledge modeling is a part, computer vision is a part. Now, one of the core component of artificial intelligence is machine learning backend. So machine learning backend mainly doing all kind of heavy lifting job of an artificial intelligence, like pattern recognition, pattern matching, data clustering, data organization. And within machine learning, deep learning is coming in a big way. Within deep learning, there are many models, like transformer model, as I said, like conversational search model, and many other things. So transformer model within the deep learning, all on a sudden came on the top after the success of GPT. And within transformer model, also known as large language model, there are different models again, like GPT, pre-trained transformer, then BART, bidirectional encoder in transformer model. So there are three major technologies coming. One is GPT model, another is the BART model from Google, and another is the Llama model from Facebook. Got it?
Okay, sir. Thank you, sir. Sir, another question is, sir,
Yeah.
actually retrieval augmented generation, is it like Google applied for its for ranking its pages? Is it like that, sir?
No. Page ranking algorithm is completely different. Page ranking algorithm, the second generation search engine is the Google, which on the top of different algorithm schemed up the top 10, 20 relevant documents in the first set of result. You have seen that Google provide result 20 in numbers per set. Each set contains 20 documents. So what will be the result included in the top 20? So that part, previous the Alta Vista hotpot all failed. They actually gathered all the documents. Most relevant documents are not coming in the top position. So in retrieval positions, and order of retrieval does also matter. Your most relevant document in one system is coming in the top 3, in another in the top 30. So that means system A is better than system B. So not only retrieving the most relevant document, but also pressing and ordering the most relevant document in the top position is a part of the retrieval now. So Google did it with the page ranking algorithm. Then page ranking algorithm, the next version of page ranking algorithm in Google created a lot of knowledge graphs. You can see now that the moment you are searching what is the height of Qutub Minar, it will give you document, but at the right hand side, it will also create a data card, the height of Qutub Minar, year of establishment, who built it, everything. So this knowledge graph is the second generation page ranking algorithm developed by Google. But it has nothing to do with the large language model. Large language model is a recent innovation. Google has not yet matched that with the system. Maybe in future, we don't know. But still it is document and links for Google. But large language model provides you answer, not the documents.
Thank you, sir. I've learned many things from your lecture. Thank you, sir.
Yeah, thank you.
I think all are satisfied, Professor Partha.
Yeah, yes, sir.
I think all are satisfied, but your lecture cannot be concluded in 1.5 hours. You
That's the
require
problem.
you require few more sessions. But since you are extremely busy, we cannot engage you.
Yeah, I
further.
understand.
I know, and that also we already discussed 1 week before.
Yeah.
Almost 1 week before we finalize the date and time.
And then also this date became very, lot of discussion.
Yes. So I'm really thankful to Professor Partha on behalf of the department, on behalf of the HRTC, and on behalf of the participants. I know it was very interesting and engaging session, and you wanted more time. He has already given 15 minutes extra, so we are really grateful to him for this. And Professor Partha, we will be in touch, and we will keep on engaging.
Yes.
We'll keep on engaging you in other
Yeah.
workshops and conferences also.
See you.
And participants, I think they have given their reaction and they have clarified their queries also. If in future you have any problem, just you can get in touch with them.
Yeah, I'm giving my email ID here so that they can.
Yes. So you can get in touch with him. And once again, Professor Partha, we are thankful to you.
Okay, bye, sir.
Thank you very much. Thank you very much.
Thank you, sir.
Thank you, sir.
Hello.